Welcome back. Now we're going to talk about understanding the teaching and learning process, Chapter 3 of the third edition of Raymond Landis's book, Studying Engineering. First, an overview of the chapter, and this is also an overview of today's talk. What is learning? How do we learn? Metacognition, meaning improving your learning process. Some points about learning as a reinforcement process. And more points, understanding the teaching part of teaching learning process. Mistakes students make, there's a long list that we'll go through fairly quickly, and seeking help. So first, what is learning? Learning is a process of acquiring three different types of things. It's classifying it in three ways. First, new knowledge and intellectual skills. That could be referred to as cognitive learning. Secondly, new manual or physical skills, that is psychomotor learning. So you figure the first one is going to be more important than the second one mostly when it comes to engineering studies. There is, though, something else about learning. This is also part of engineering study and more important for this class, and that is new emotional responses, attitudes, and values. Could be referred to as affective learning. And that's one of the main hopes of your author and us when we teach this course. We hope that you will learn some things that change your attitudes, your values, your approach to school so that you will be successful in school. As far as learning, there is a famous classification for levels of learning. This is, of course, somewhat arbitrary, but it's very telling. This goes in increasing levels of learning. The most basic type of learning is remembering. That's certainly a part of it. You can get some points on a test maybe with remembering, but that's definitely the lowest level of knowledge. If you think that's what college is about, you're really missing out because that's all on Wikipedia pretty much, a lot of remembering. So that's not really what the higher level of learning is about. Understanding is next, understanding what you are remembering, knowing what it really says. Doing something with that. A heck of a lot of sophomore engineering courses and math courses, whatnot, are this, applying, taking this skill and actually doing something with it, a new problem you haven't worked before, but still, very tightly knit type of problem that you've seen. You've seen examples of this, but you haven't seen the exact same problem. This slightly different problem, applying those skills is a type of learning. Then beyond that is a little bit higher level, taking all that understanding and ability to apply a method and actually coming to some kind of conclusion from that information. You can go farther into evaluating. These are the standard steps. And eventually, when it's all done, when you get all the way through, you get to creating. Creating is the design process. That's ultimately what engineering is all about. Creating solutions to problems, often involving technical things, difficult issues that people are having, helping with those problems, designing a solution, creating a solution. That's what engineering ultimately is about. So that's the ultimate goal. That's why we have a class like Engineering 113 early in the studies of engineering so that you can get a little taste of design. Maybe you've been on some other school design project in the past, maybe at your high school or whatever, a robotics team or something, where you actually did have to design and build something. But that is ultimately the goal. That is the highest level that we're trying to get you to. How do we learn? There's two categories, two subjects here. Receiving new knowledge is the first step, and processing that knowledge is the second step. A little more detail on that. Receiving new knowledge, what type of information do you prefer? So we're going to classify the type of learner that you are. This is somewhat helpful to you. Should help you to self-evaluate a little bit in the process of learning and affect that learning process a little bit. Are you a sensing learner? Are you an intuitive learner? That's one of the classifications. In what sensory channel do you perceive external information most effectively? There's two kinds of learners here. Visual learners see it versus verbal learners, they hear it. Of course, the lecture tries to get both across maybe, but some people are one or the other, more one or the other. Then it comes to processing new knowledge. You might process new information as an active learner, actually doing something with it, versus someone who likes to reflect on what you've seen, what you've been told, focusing on it after the fact. The way you progress towards understanding, again, one of these two, you might be a sequential learner, you might be a global learner. Most of engineering and math type subjects, physics is taught sequentially, starting with one concept and building up, but not exclusively, and not everyone's a sequential learner in the sciences. I try to teach the ENGR101 class, the programming class, a little more globally than other classes. I try to give the big picture. I often throw out a little bit more advanced things. What I find is that some students really like that. It really helps them to see the big picture at the start. Other students get real panicky when they see the big picture. They think, oh, that's too big of a step, right? And they think they need to be able to grasp every little detail right off. And that's, so we still have the steps. We try to make it work for both students, types of students. But you have to understand there is two kinds of learning, sequential, step-by-step, tell me what's next, and so on, so you grow into a more complicated, or a better understanding, a deeper understanding, ability to handle more complex problems. But many students really like to know what's the big picture, where are we headed with all this? So hopefully the teacher can give both of those and help both those kinds of learners. There is an index of learning styles online. This questionnaire I encourage you to take. It's Index of Learning Styles questionnaire located at this website. Go there. You can take this 44-question test, and it's just A or B on each one. After you do that, pick the A and B. Obviously, you want to be honest because this is just for yourself. There's not going to be any record of this. It's just a website that doesn't send any information anywhere. So just go there, do it. It might tell you something useful. It's going to classify what type of learner you are based on those 44 A, B, true-false questions, essentially. It gives you an immediate score right there on the website. It doesn't know who you are or anything. Just do it, think about it. Might come back to it in the future. Try to understand what kind of learner you are. That will help you. All right, so improve your learning. A couple facts. You need to observe your learning. You need to use those observations as feedback so that you can improve. You make changes to improve your learning process from that feedback. So here's some interesting items that define expert learners. You want to be an expert learner. You're just starting out in college. You've got a long way to go. A lot of tests you're going to take, a lot of homework assignments, a lot of labs. You've got a lot you're going to do. You might as well invest a little bit of time early on becoming an expert learner. And here's some characteristics of expert learners. You might not have all these by the time you're graduated as an engineer, but hopefully you will have developed many of these. First, expert learners control the learning process rather than becoming a victim of it. Expert learners are active, not passive, in their approach to their learning. It's not just the teacher's the boss, tell me what to do. If you take that attitude, you won't be an expert learner, that's for sure. You won't get as much out of it. You won't fill in the holes that you really need filled in. So you need to be an active learner. Expert learners are motivated. They, for example, enjoy learning. They have short-term and long-term goals. So you really need to be passionate and excited about your studies. You'll be an expert learner with that, or that helps you be an expert learner. Expert learners are disciplined. They have learned good study habits, and they use them consistently. That's a problem for some students. I've seen students that don't have good habits, and even though they should be successful, they don't succeed or they don't do as well as they should. Expert learners are more aware of themselves as learners. They know their own strengths and weaknesses. So that's part of what that test was about. Understand what your weaknesses are so you can work harder to overcome those weaknesses when you're having to deal with them to get through a test or whatever. In addition, expert learners initiate opportunities to learn. They go out of their way to learn stuff. They don't just wait for things to come to them. Expert learners set specific learning goals for themselves. Again, part of being motivated, having goals. More characteristics. Expert learners have a larger repertoire of learning strategies from which to choose. They don't just have one way they can learn, they have multiple ways they can learn. They know not only what to learn, but how to learn is an aspect of expert learners. Expert learners plan their approach to learning. They actually think about what they're going to be doing this semester, planning things out, ways to do their best so they can get good grades and get a good understanding of the content. Expert learners monitor their learning while it's happening. They actually do self-evaluation of them, evaluate themselves so that they can make adjustments, make improvements, make sure they're on the right track to success. Expert learners are more adaptive because they self-monitor while learning, kind of the same thing. Expert learners reflect more upon their own learning. Expert learners evaluate the effectiveness of learning approaches and strategies. So part of that self-evaluation is what worked, what didn't work. I used this special way of taking notes. Did it help me last semester? Did it not help me? That sort of thing. Expert learners use learning strategies selectively. So as opposed to just doing one way I'm going to learn in every class no matter what and just always trying to force every class into the same box, they'll use different strategies for different classes. They'll use the ones that are best for them rather than just reading on a website somewhere, this is the way you learn best. They have their own ways and they use different ways for different classes and different situations. Expert learners tend to attribute failures to correctable causes. Along those lines, expert learners tend to attribute successes to personal competence. I remember some years ago when I was working with some people on a Women in Engineering scholarship program that National Science Foundation did a big study comparing women engineers to male engineers, and they found that stereotypically women engineers tended to internalize failures and male engineers tend to externalize them, engineering students. Whether that's still true or not, I don't know, but the fact is that there was higher attrition at the time of the female engineering students, and they were trying to find ways to look for differences, and one of those was that students who tended to blame themselves more were more likely to switch out of engineering to some other major. That first time you get a C on a test, or then you don't want to see, maybe you're used to being an A student all the time. I've seen this, I've seen some students who are all A students, they get a C on a test, like, oh my gosh, I'm so dumb, I got to get out of this, right? Well, that's a bad overreaction. The students tend to, who look at the cause, an external cause, why did I not get an A, why did I get an F, or why did I get this bad grade, whatever. What do I need to do then to fix it? These are fixable problems. These are not problems that I could just look at myself and say, well, I'm obviously not cut out for this. That's the wrong answer, definitely. Correctable causes, that's the point. You can, if you have a bad test or a bad class or whatever, something goes wrong, fix it. That's all it means. All right, so some aspects of learning as a reinforcement process. Learning is a reinforcement process. That's the first point. Reinforcement, lots of reinforcement. Not one time, not even 2 times. American education is set up so it's 4 times at least that you see this material. So first, before class, you should prepare for the lecture by reviewing notes, reading text, attempting a few problems, formulating some questions. All of this happens before class. So many students, especially as they get further in their education, they just show up, tell me what I got to know, tell me something, let's hear it. What are we doing today? That's not, you're missing on one of the steps. I said 4 steps. You're missing one of them right there if you don't come prepared. Do what you can. Try to work a couple problems, just maybe some of the more basic ones. Look at the example problems especially. Read the material that's in the book for the assigned reading material. Then, after that, it comes during class. Attend lecture, obviously. Don't miss lectures. That's a huge mistake. Concentrate intently. Take detailed notes. Ask questions. Ask questions. One of the most important things. Some students just sit in the back, take their notes. If they don't understand something, they say, well, I'll figure it out later. Often they don't figure it out later. So ask questions. The people that ask the questions early on, eventually they're the ones that are answering all the questions. All right, so that's first 2 steps. Next step, after class, but before the next class meeting. Review and annotate notes, reread text, work assigned problems, work extra problems if there's time, hopefully, or if you're lacking in some level of understanding, you're not sure, go ahead and work a couple extra problems. Make sure you can do those problems, especially if they've got the answer in the back. You know, just work on them. Don't look at the answer until you've actually made it to the very end. Once you've made it to the very end, you've got an answer, then check the answer in the back. Meet with a study partner or study group to go over material and problems. All of that before the next class period. And also you need to prepare for the next class period. Then, in preparation for a test or exam, review notes, review text, rework problems. Hopefully it won't take you very long to rework those problems because you already understood them earlier, but now you're going to rework them. It's just going to remind you how to do the problems. Meet with a study partner or study group to go over material and problems. All of that should take less time than normal. If you've been doing the earlier steps, you won't have to cram as much for the tests when they come up. And then finally, the final exam, assuming it's a comprehensive final exam that covers all the problems, all the methods or whatever for that course, then you should review notes, reread the text or parts of the text, rework problems. Now, as far as reworking problems, probably you're just going to get started. You know, remind yourself of each problem. Maybe you don't need to work it all the way to the end. You probably won't have time to work every problem over. You certainly wouldn't have time. But you could at least get started on every problem. Make sure you know the key steps, the big picture of every problem that you did for homework. And definitely the test questions. If your instructor gives your tests back to you, go look over all those tests because that's usually the stuff the instructor thinks is most important, is most likely to put similar questions on the final. Meet with a study partner or study group, go over the material and problems. So that's the steps, right? Bang, bang, bang. Really, I think I showed it as 5 steps, but there's repetition. That's how American education universities works. So get used to it. All right, so teaching modes. Large lectures, small lectures, recitation sections. These might be problem-solving sections with a grad student, something like that, or just a little extra practice, and one-on-one tutoring. These are all ways you can learn or be taught. People can provide information to you. Now, your instructor, your author, Dr. Landis, is not particularly fond of this. It is typical that this is how the teaching process occurs. In each case, there is the expert. The expert is communicating the knowledge they have of the subject matter to you who doesn't have as much of that specific knowledge. Generally, most of this communication is one way. Hopefully there's a little back and forth with some questions so that the person can really focus on the stuff that you need help with. It's particularly good if some kind of a one-on-one meeting with a teacher or a tutor. But still, it's mostly going one way. And relatively little learning takes place. That's the secret here, the point here. You don't really learn that much. You learn what you need to know, but you still don't know it. You haven't practiced it. You haven't reflected on it. You haven't done anything with it. You haven't done much of the steps that's involved in being a learner. All you've done is have some information hit you, and at that moment, you're still up at the lowest level of understanding at best, assuming you remember what you were told even. So you got to move it yourself down that list to get a better understanding. All right, 5 aspects of teaching styles. Teaching styles that are most prevalent in math, science, engineering are highlighted in bold here. First, what type of information is emphasized? One possibility is concrete. It's facts, data, observable phenomena. That's not actually the most common method in the engineering or sciences. Mostly the presentation involves abstract aspects, principles, concepts, theories, mathematical models. That's most of what we do. Not that there's not presentation of facts, but abstract is most of what you see. That's kind of what engineering education is. It's teaching you procedures and concepts, ideas. It's making you a thinker and a learner, as opposed to stuffing a bunch of specific facts into your head. That's not what engineering education is about. What mode of presentation is stressed? Possibilities visual, such as pictures, diagrams, and such, demonstrations, or verbal, spoken works, written words. Spoken words, written words. that's the second one, verbal. Most of it is a lecture, instructor talking, explaining things. There's going to be some of that other. Different instructors will use different amounts of visual materials to support their lectures, but most of what you're going to see is verbal presentations with maybe some writing on the board. How is the presentation organized? Deductive, start with fundamentals, proceed to applications. That's typical in the sciences and math and engineering. Or inductive, start with applications, proceed to fundamentals. Again, sometimes the instructor might work it the other way and start with an example you're familiar with and then say, well, let's talk about now this more broad principle. It's neat when that can be done, but most of the time it's the other direction. Here's the principle. Let's see some applications of it. Fourth aspect, what mode of student participation is facilitated? Actively involving students, talking, moving, reflecting, solving problems, or passive, student as spectator, watch, listen. Passive is most common. You're going to see a lot of that. You won't see nearly as much active. Obviously, it's fun when that can be done. Labs can be really cool. Design projects can be great. Those are some of the most exciting aspects of engineering education. But the nature of the way it's taught, most of it is the passive approach. You have to get a more active aspects to your education, to get more active involved. You have to go outside of class and be on design teams or do your own research, write your own computer programs, whatever, to become more active in the learning process. What type of perspective is provided on the information presented? Sequential, step-by-step progression versus global content and relevance are provided. A lot of science, math, engineering is presented sequentially. We know this, that leads to that. The global aspects, again, are harder. It's great, though. I mean, that's when students really get interested. So I know teachers like to, as I as a teacher, love to get into the more global ramifications of what this specific fact relates to, and I like to talk about that. But the nature of engineering and sciences and math is that it tends to be step by step. Important questions related to the way your professors teach. One question you might ask is, what value is it to me to understand how my professors teach? I'll let you think about these and read your book and think about that a little more, but because there's a quick answer, but I want you to think about these questions. What if the way I prefer to learn differs from the way I'm taught? Certainly there's things you can do about that, but I want you to consider that on your own. And why don't my professors use a variety of teaching styles? Try not to be too cynical here. Obviously certainly my colleagues at the community college, they love to use different styles. They want to use different styles, but they can't always, or they don't always. So again, you can think more about that question though. So mistakes students make. This might seem a little preachy. Some of it's not rocket science at all. It's just really basic stuff. But as a teacher, I know I see these mistakes over and over again, and I hope you won't make them too much. You're going to make some of them, of course. Everyone makes mistakes, but hopefully you won't make too many of these mistakes. Some of these are obvious. Some of them are maybe not as obvious. First, students mistakenly assume engineering study will be like high school. It's not. Sorry, it's not. There's no way. The farther you go, especially. So work to understand and adjust to the differences between high school and engineering study. I really have seen in my teaching some seniors in mechanical engineering versus teaching freshmen in engineering. The same students moving from being freshmen to being seniors, I've seen them develop so much. They change so much as they start to understand how engineering study works. And one big difference is simply just how self-motivated these students are, how good of learners they are. It comes to the point where as content is presented, information is presented, the more advanced engineering students, they just know how to know whether they've learned it or not. If they don't understand something, they figure it out. If the teacher isn't clear, they ask questions inside and outside of class, they do their own research, they check the book, they work together, they find out the answers so that they're ready. When the test comes, they'll have the material, they'll understand it. Or when it comes to these projects, they go the extra mile, do what it really takes to understand the material. Teacher is not going to act, teachers in college are not going to act the same way that teachers in high school act. So that's more of it. I could say a lot about this subject, but just there definitely are differences. Second, students will program themselves for failure, maybe not realizing it, but they essentially set themselves up for failure with their schedule or their approach. Create a life situation that enables you to devote adequate time and energy to your studies. So it's time management, it's planning, making sure you're not overworked, make sure you have plenty of time before and after class to do what it takes to be ready for class and to follow up after class. Set yourself up for success, and you will succeed. Students mistakenly spend little time on campus. We especially see that at the community college, where students schedule things so they can arrive right before class and bust out of here right after class. That's a poor situation. It's not ideal at all. If you can avoid that, please do. You can have more chance to meet with study partners, more chance to visit with your instructor outside of class, or go to the tutoring center or whatever, spend time at the library. If you just race in, race out, you're definitely not going to it's a mistake. So immerse yourself in the academic environment of the institution. That's the lesson. Students mistakenly neglect studying. That's, I suppose, pretty obvious. Schedule your study time. Students, you're smart people. You know you got to study, but some students, I think, some of the students will lie to themselves. They think they're studying more than they are. They think, oh yeah, I studied 2 hours a day, or I study 4 hours a day, or whatever. But when you actually look at how much time you studied, it's a lot less than that. Schedule your study time, and during that time, really do it. If you miss it, make it up. You got to put in the time. Now, I can't tell you exactly how much. You got to put in the amount of time that it takes, whatever that is. But it's not a small amount of time. Okay? To get the most out of school, to get the good grades, put in the time early on. It's a progressive program. Material in later years depends on earlier years, so you need to put in the time, especially early on, so you'll get good grades all the way through. Students mistakenly delay studying until the test is announced. That's a mistake. Master the material presented in each class prior to the next class. Boy, I can really tell the difference between students who do that versus students who don't. It turns out this is a mistake a lot of students make. They don't do enough between classes, but the students who really do follow the suggestion of reading, preparing before and after class, getting ready for the next class, they get so much more out of class. Their questions are so much more valuable to them. They really just do really well in the subject matter, earn A's usually, and that's a great tip that a lot of students neglect. Study 100% alone. Some students get the idea that they'll be stronger and smarter for doing everything on their own. That's probably not true. You're going to learn more, you're going to learn faster working with partners. It's just the facts. That's another National Science Foundation study comparing, at the time it was certain ethnic groups were doing really well in school, and a lot of it had to do with their method of all working together, all the group helping each other, not moving on until the whole group had it figured out. At times that's a real pain. It can slow you down, it seems like, but actually often can highlight areas that you don't understand things as well as you thought you did. You may be the really strong student, but the act of explaining it to someone else who's not as far along as you will frequently help you learn the material. You'll find out that you didn't know something or you had neglected something, and you try to explain it, you say, oh yeah, I had never thought of that. So being in a study group can be very valuable. Don't do it all alone. Obviously there's going to be a lot of alone time in studying, but work with a study group also. Come to lecture unprepared. That's kind of already harped on that. Don't do that. Review your notes, read text, attempt problems prior to each lecture. Avoid professors. Students tend to do this. They tend to never come see their professor in office. I know especially at the community college, but I'm certain there are many people like this at the universities too, that they got into this because they love teaching. They like working with students. They want to help them out. They want to answer the questions. That trip to their, students coming to see them, or it can be email now. I do a lot by email, and quite a few teachers do. But whether it's phone call, email, or visit to office hour, interact with your professor. You'll get more out of your studies, and it often can help the professor too, because the professor often will get that feedback from students to remind them, oh yeah, I forgot to really hit on that. I forgot to do that example problem or whatever. That feedback's good for the whole class. So don't avoid your professors. There's other reasons besides how well you'll do in that professor's class. Professors, I think you can read this in your book, professors can be valuable, contact with professors can be valuable in other ways. Cut classes, students mistakenly cut classes or don't get the most out of lectures. Cutting class, like I'll see some students will cut class so they can get homework done in another class or prepare for a presentation in another class. It's kind of a slippery slope because now you're going to be hurting yourself in that other class. Try to budget your time, manage your time so that you don't have to miss classes if at all possible. It really hurts your study efficiency. The classes are designed to make studying more efficient so you'll do better on tests and be able to focus on the content, and so hopefully the instructor is able to hit on the points that you have the most trouble with. Our students typically have the most trouble with. That's what class is all about. So don't miss class. As far as when you're in class, you need to practice good listening skills, ask questions. Students sometimes fail to take notes or to use the notes properly in the learning process. Suggestion, of course, take effective notes and use a systematic learning methodology to study from the notes. So learn how to take notes. Take a little bit of time. There's sources out there, suggestions in your book, online sources. Spend a little time learning to take notes. I was never the greatest note taker, so I'm maybe not the best person for asking about that, but one thing I know I did well was when I had time to read the material ahead of time, when I showed up to class ready to go, I know my notes were very good because I would sometimes write in my book. Other times I would just take limited notes, very carefully prepared, and identifying what page number they're related to in the book, so that because I already knew the material sort of, my notes were very dense, but really hit the high points of things I needed, as opposed to just writing everything down as fast as I could that the instructor put on the board. So that's one tip I can give, but mostly just, you need to know what works well for you. You need a note-taking method. Students mistakenly skim over material in an assigned chapter in a rush to get to the homework problems. I've seen students who don't even look at the chapter. They go straight to the homework problems, hoping that the lecture was enough to get them through the homework. That's obviously a mistake. You're not going to get as much out of the material. Use reading for comprehension methodology to understand general concepts before attempting problems. The problems will be much more useful to you if you understand the bigger picture, if you've read the text, you've read the example problems. So please take the time to do that. I think this might be coming later, but I want to make sure this is clear. Some students seem to think they need to memorize exact solutions to homeworks, and that's their approach. But that's not at all what the physics and engineering classes are about. They're about techniques and general approaches. It's quite possible you'll get on an engineering or physics test and every single problem on there is a new problem to you. And if you just memorized a bunch of homework problems and you don't really know how to use the methods that were used in those problems, it's going to be very hard for you to work the new problems. You need to practice the homework problems as if you didn't know how they were solved and you didn't know the answer, and you work through it so you understand the techniques. And then when you see newer problems, they're very similar problems, but they're still different, you'll be able to do it. So that's part of the reading for comprehension, is also when you work the problems, comprehend what's actually going on. So that might be part of this also. Fail to solve assigned problems. Don't approach problems in a systematic problem-solving method. Obviously, one solution to that is don't just do the assigned problems, but work extra problems. Use a problem-solving method. Now that problem-solving method has to do with certain techniques you'll find in books, especially in the physics and engineering books, but also the math books. When it talks about word problems. Almost all the engineering problems are word problems. They typically will give, in every engineering textbook, some sort of in the first chapter, some sort of a suggestion, or how do I solve problems in this subject matter? Typically they involve figuring out what's known, figuring out what you got to know, that sort of thing. And then there's other steps in between, like in thermodynamics, we say, well, you better write a property diagram, or better show your property diagrams, as an example. So those kind of steps that are in there for that subject matter, use those steps, use that methodology. That way you can apply that to many different types of problems. All right, so seeking help. Don't be afraid to seek help. Here's a quote. "If I have seen a little further, it is by standing on the shoulders of giants." Famous scientist, Newton, obviously giving credit to people that came before him, even though he's more famous probably than almost any of them. The point is that we all use others for getting started. As far as help, and by the way, the word help is in quotes because that word can be misconstrued, but help can come from your peers and from your professors. Help doesn't mean, oh, can you let me copy your homework, obviously. Help means, I don't know why, I feel like I'm doing this perfectly, but I don't know why it's wrong. Why is my answer wrong? Show it to your buddy. Your buddy looks at it and says, oh, you accidentally did 7 times 3 is 28 instead of 21 or something like that. You did a simple multiplication mistake. Your study partner can help you with that kind of thing. That's what help involves. Or other types of help, but maybe a little higher level than that. But the point is, use that help appropriately. Use that help, though. You need to work with these people. Don't do it all by yourself. That will not work as well. All right, so a key finding, a key result here that you need to remember from this presentation: students who get the most out of college, who grow the most academically, and who are the happiest organize their time to include interpersonal activities with faculty members or with fellow students built around substantive academic work. So be part of the school, be part of the learning, research, projects, whatever, student design competitions, study groups, anything extra fun things the engineering club's doing, that sort of stuff. Don't just get together to play computer games or whatever. That doesn't count. That might be fun, but it's not what they're talking about here. Do some of these things and you'll be better off academically. You'll get the most out of college. There's a group projects associated with this. Please take part of that. And a couple comments I had. This is big as far as your author is concerned, Dr. Landis. He really wants these sorts of talks to change your behavior, to actually allow you to do better in school. Don't just sit and listen and say, oh yeah, I agree. Pick a few things that you agreed with from this presentation and really make them happen for you. Really try them out. Be really serious, at least a semester, maybe longer. Give it a try. Then after that semester or two, look at those things you're doing. Are you still doing them? Did they help? Are there any other things you should be doing? Go back and reread this book for this class. Look at these suggestions, and really make a change in your studies, and then you'll get better grades, a better understanding, better engineering job. So, but that's it for today. Thank you.